Welcome back to Cloud Cost Clinic. If you have ever opened your AWS bill, seen a charge tied to networking or your VPC, and thought, wait, I thought a VPC was free? You are basically right. The VPC itself is free. What costs money is the stuff you attach to it and the traffic that flows through it. In the next few minutes, I will walk through the handful of things inside a VPC that actually cost money, where to find them in Cost Explorer, and what to check before you change anything. Because networking cleanup is one of the easiest ways to turn a cost review into an outage. Here's the mental model. Your VPC, your subnets, route tables, and network ACLs are the container. On their own, they are generally free. The charges show up when traffic moves and when you attach paid services to that container. So, VPC cost is almost never the VPC itself. It is usually one of about 5 things: NAT Gateways, data transfer, public IPv4 addresses, VPC endpoints, and a handful of networking services like load balancers and transit gateway. Let's go through the ones that surprise small teams the most, starting with the loudest. NAT Gateway is the #1 VPC cost surprise. It lets resources in a private subnet reach the internet for updates, package installs, outbound API calls, without being publicly exposed. The catch is that it bills 2 ways: an hourly charge for every hour it exists, plus a per gigabyte charge for all the data it processes. So it is a toll road. The longer it runs and the more traffic you push through it, the more it costs. AWS documentation has the current rates. I'm not going to quote a number because pricing changes, but the shape is hours plus data processed. The common pattern is that a team moves workloads into private subnets. The architecture gets more secure, and the bill quietly grows a toll road habit. Next is data transfer, and this is the sneaky one because there is no resource to point at. It is just movement. 2 patterns matter most for small teams. 1. Data leaving. AWS to the internet usually has a per gigabyte egress charge. 2. Data crossing between availability zones inside your VPC often gets charged, and frequently in both directions. So, 2 services chatting across AZs or an app and a database split across zones can quietly add up. Traffic within the same availability zone over private IPs is usually free. The point is not to cram everything into one AZ that affects resilience. The point is to know which traffic path you are actually paying for. Public IPv4 addresses. This one changed in 2024. AWS now charges an hourly rate for every public IPv4 address, whether it is attached to a running instance or just sitting there idle as an unused elastic IP. Always check current pricing, but the takeaway is that idle public IPs are no longer free. An unassociated elastic IP is a strong review signal, but it is not automatic proof that it is safe to release. A public IP can be tied to DNS records, firewall allow lists, or a vendor integration. So treat it as a review candidate, not a delete button. VPC endpoints are interesting because they can cost money or save money depending on the type. Interface endpoints, powered by private link, charge an hourly rate per availability zone, plus a per gigabyte data processing charge. So a pile of interface endpoints nobody remembers is just another recurring baseline. But gateway endpoints for S3 and DynamoDB are different. They do not carry that hourly charge, and they can actually reduce NAT gateway data processing by keeping that traffic off the NAT path. So, endpoints are not simply good or bad. The questions are, which type is it, how much traffic uses it, and is it still doing the job it was created for? A few more line items live near your VPC and show up on the bill. Load balancers bill hourly plus a capacity and traffic charge. Transit gateway bills per attachment plus data processing. Site-to-site VPN bills hourly plus data. VPC peering is interesting. The connection itself is cheap, but the cross-AZ or cross-region traffic over it is what costs. And VPC flow logs. The logging toggle is simple, but the destination, the volume, and the retention create the cost. You do not need to memorize all of these. You just need to know that networking on your bill is never one thing. It is a stack of usage types you can pull apart. So where do you actually see all of this? Cost Explorer. Start by grouping by service. You will see things like EC2-other, Amazon VPC, elastic load balancing, and data transfer. Then take the biggest mover and group it by usage type. That is where the real story is. You will see usage types like NAT Gateway hours and NAT Gateway bytes, regional data transfer bytes for cross-AZ traffic, data transfer out for egress, and public IPv4 address hours. Then compare the daily trend. A flat line usually means you are paying for something that simply exists, like gateway hours. A climbing line means traffic. The exact names vary by account and region, so read what is actually there instead of guessing. Here is the mindset before we touch anything. A high networking number is a signal, not a verdict. Expensive can be completely valid. A NAT gateway you actually need. Cross-AZ traffic that buys you resilience. Mysterious is the real problem. The goal of this review is not to delete the most. It is to make the traffic path explainable. Which path are we paying for, and is that path intentional? Before you change a single route, endpoint, or address, verify a few things. Which application depends on this path? Is the traffic production, batch, backup, or monitoring? Do DNS, security groups, route tables, or external allow lists depend on it? Is it part of failover or disaster recovery? Would moving an availability zone hurt resilience? And has rollback been tested? For production networking, use a change window. A lower bill is not a rollback plan, and a dashboard will not attend your change review for you. When you do act, the safest fix is usually smaller than the first idea. A few low drama levers. Add gateway endpoints for S3 and DynamoDB when that traffic is going through a NAT gateway today. Release clearly abandoned public IPv4 addresses after an ownership check. Keep chatty resources in the same availability zone where the architecture allows it. Right size or consolidate NAT gateways only after you have mapped which subnets route through them. And tag networking resources with an owner, app, and environment so the next review is faster. Sometimes the right answer is a route change, sometimes it is a tag, and sometimes it is accepting the cost because the resilience is worth it. So, quick recap. The VPC itself is free. The cost comes from NAT gateways, data transfer, public IPv4, endpoints, and a few networking services around it. Find them in Cost Explorer by usage type and verify the traffic path before you change anything. If you want a head start on guardrails, there is a free AWS budget plan and a free AWS cost checklist at cloudcostclinic.com and a full written version of this in the VPC cost guide linked below. If this helped, subscribe. I publish practical AWS cost walkthroughs like this one. And tell me in the comments, which VPC cost is hardest to explain in your account? NAT, endpoints, public IPv4, load balancers, or data transfer? Thanks for watching. Don't forget to subscribe.